looking decimals. Yeah. So in this one here, when you have y equals negative 2 x to the 1/3, that's the exact same thing as saying y equals negative 2 cube root of x. Okay? So the x has just the cube root of it. All right? Because it's not in parentheses. So from there, that's when you go ahead and you do your cube root function. And then when you're doing the cube root stuff, let's see, it's going to be 2 times the cube root of negative 8, 2 or negative 2, negative 2 times the cube root of negative 1, negative 2 times the cube root of 0, negative 2 times the cube root of 1, negative 2 times the cube root of 8. That's how you're getting those values. So this would have been negative 2 times negative 2, which was 4. It should have been 2, 0, negative 2, and negative 4 for the points then, I believe.
Wait, can you put that in our calculator?
Yeah, you can. It's not a problem. Yeah, if you want to put if you put it in the calculator, you're going to get the same result. So your generic one, as far as, well, this one isn't so bad because you don't have a shift here involved. So all you had to do was just plot those points. At negative 8, it was 4. Negative 2, 2, 0, 0, negative 2, negative 2.
It's not negative.
Wait, what am I graphing here?
It's negative 1, 2.
Oh, yeah. I'm sorry, I was going backwards there. Good morning. Negative 8 and 4. Negative 1 and 2. Thanks. 0, 0, 1, negative 2. And then 2 and negative 4. Or, sorry. Yeah, negative. Yeah. So, for some reason in my head I'm going, why does this look so weird? Because it's not a square root function. Duh, it's going to be, it's the cube one. So, I just, brain fart. So that's what it should kind of look like. There was no shift involved, so you should just have that one. Yeah. Yeah. Since it's just a square root, you're just moving it over to the left 6. So you use one of these, you just move each one of these. That's exactly what you did. Perfect. What else, guys? 38. So in 38, we're going to kind of do the exact same idea that I just did. Bless you. What we're going to do is we're going to plot the y equals negative 3 cube root of x. We're going to plot that one first, because that's going to be the parent function, and then shift everything to the left or to the right? To the left, how many? Correct. Do they go up or down at all? No. So when you get your generic, bless you, when you get your generic function for that, let's see, it would be 0, 0 at negative 1 at positive 3. At negative 8, it'd be positive 6. And then just mirror it on the other side. So that is your generic. And now since your h value is negative 4, I'm going to take each one of those and move it to the left 4 spots. Eight, 4 is your h value, h and k. That's all. And this one will be over here. Okay. Does that make more sense on that? Remember, whenever your a value is not equal to 1, use your calculator to plot the parent function and then just shift it. Taylor, what's wrong?
In your calculator, you just put the negative.
In my calculator, I'm just going to put this.
Oh.
All right. But if you remember, the cube root function you're using 0, 1, and 8. The cube root of 8 is 2. I just multiplied it by -3. I got -6. So I'm doing some of those. So if you don't remember that in your head, you can create that table in the calculator. It's fine by me. I'm not going to require that you do that by hand. Okay? Yes, ma'am. Sure. Oh, this one is one of those weird shifts. You just have to shift with the 3/4. What happens here when you do your parent function here is just the generic cube root of x. There really isn't. When that one looks like, remember when you have your parent function of this, it was 0, 0. This is positive, so it's 1, 1, -1, -1, then -8, -2, 8, and 2. And with each one of these points, then, there is no horizontal shift. It's just a vertical shift up 3/4. So you don't go up a full, you just go up kind of full. How about here? How about here? How about here? How about here? All right. So it's not quite 1. Oops. And that's what stinks. I promise you guys on a test for this stuff, your shift points were going to be normal. Okay, they're going to be at such a value that you can actually move it and it fits on the graph and all that. I'm not going to give you ones that your A value is going to be horrible for decimals and stuff like that either. Okay. Is that fair?
Yeah.
Because if you can move it left, right, up, and down 1 or 4 or whatever, does it really matter if you can count 3/4? Okay. Does that make sense? All in all, I'm hoping it wasn't so bad, was it? Did you guys get the email that I told you that I recorded the entire lesson for this stuff in period 8, 9?
Yeah, I watched it.
Makes sense? I was probably haunting you. All right.